what is the probability of drawing a spade and then a face card? Well, drawing a spade is not a problem. We know how many spades are in the deck, but then look at the next question. It says, and then a face card. Well, what if that spade that we drew, the first card, what if we drew a spade that was also a face card? Now there'd be one less face card for our second card that we need to draw. Or the spade maybe was not a face card, and then we would have all 12 face cards of which to consider. So A is a spade, event B is a face card. So the probability of A happening and then B, we need to split this into two separate events. The first event, let's say that the first card is a spade, but not a face, and then our face card. So we're going to assume that the spade that we draw is not a face card, and then we'll have all the face cards left for our second draw. And then we could also consider the event that the first card's a spade, has to be a spade, and is a face. And our second event being the face card. So let's look at how this probability would work. We're going to assume to start here that this spade that we've drawn is not a face card. So we need to ask ourselves, how many spades are in the deck? Well, there's 13. And how many of those 13 are not face cards? Well, it's not the king, queen, or the jack. So there's 10 out of the 52 that are spade cards that aren't face cards, times now the probability of drawing our face card next. Well, since we did not draw a face card to start with here, there should be 12 face cards in the deck. The king, queen, and the jack, and the 4 suits. So 12 face cards out of 51. Plus, now let's assume that there was a spade, and that spade was a face card. Well, there's where the king, queen, or the jack are coming in. So 3 out of 52, assuming the first card was a face card. And now the probability of drawing a face card would be 11 out of 51. And when we work this out in the calculator, we get 3 out of 52. So the probability of drawing a face card first, drawing a spade first, followed by a face card, would be 3 out of 52. We're going to take a look at something here that we call Bayes' law. And Bayes' law helps us with some conditional probabilities when we have already learned something about the outcome. So if we're asked to find the probability of an event A, given that, remember the slash means given that, so the probability of an event A, given that B has already occurred, the formula works out to be equal to the probability of A occurring times the probability that event B occurs, given that A has occurred, divided by the probability of B. So let's take a look at an example that will show us how we can apply this formula to this particular question. So here's a scenario. We got some factories that are producing light bulbs. Factory A produces 70% of the light bulbs that this company produces. And in this factory, 3% of the light bulbs that are produced are defective, don't work. Factory B produces the remaining 30% of the light bulbs, and 4% of those light bulbs are defective. So the question is, you get home, you bought this light bulb, and it doesn't work. So suppose you get a defective light bulb. Question is, what's the probability it came from factory B? What's the probability that this broken light bulb was made in factory B? So you see, we're given something about the outcome already. Suppose you get a defective light bulb. We know this light bulb is defective. We're given it's a defective light bulb. Anytime you see words like suppose something has occurred, or given that the light bulb is defective, these are sort of your key words to think about it as a Bayes' law question. Suppose or given that. So you're given some information about the outcome. Now, what's the probability it came from factory B? So I'd encourage you to write down what events A and B represent. Probability of A, the probability it came from factory B. So event A is going to be factory B. And then given the event B is that it's defective. Okay. So this question is asking, what's the probability it came from factory B given that this light bulb is defective? Well, now it's simply a matter of applying the formula. First part is to figure out what is the probability that the light bulb comes from factory B. 30%. So the probability of event A is 30%. Now, what's the probability that it is defective, the probability of B, probability that it's defective, given that it came from factory B? So what's the probability it's defective, given that it's come from factory B? 4%. So times 0.04. Divided by probability of B, the probability that a light bulb would be defective. Well, again, that depends on which factory it comes from. The probability that a light bulb would be defective, well, there's a 70%, 3% of the 70% of them are defective. So this would be the probability that it's defective coming from factory A, plus, or the light bulb could have come from factory B, and the probability that it would be defective coming out of factory B is 4% of the 30% that are produced there. So we simply need now to go to the calculator to determine what this probability would be. So 0.3 times 0.04 divided by bracket 0.03 times 0.7 plus 0.04 times 0.3, close the bracket, equals 0.36. Or in other words, 36%. There's a 36% chance that if you get a defective light bulb, that one would have been produced out of factory B. So that's Bayes' law. Keep in mind, we only use Bayes' law when we're asked to find the probability of something when we're given something about that outcome already.
If you are asked to find the probability of an outcome A, given that B has occurred, then the probability of A given B will equal the probability of A times the probability of B given A divided by the probability of event B.